Have you ever really thought about the metal parts that, keep our world from falling apart? I'm talking about the components in your car, the frame of an airplane. They look so simple, but inside every single one is this hidden story of creation, of trial, and frankly, of survival. Today, we're going to pull back the curtain on that story. How these metal objects we trust our lives with are made strong, safe, and ready for anything.
So let's just dive right in. The big question is this: how does a simple lump of metal get transformed into a high-performance part you can literally bet your life on? It's definitely not magic. It's a super controlled and honestly a fascinating journey from start to finish. All right, every hero's journey has a beginning. And for our piece of metal, it all starts here, as a fiery, glowing liquid, just waiting to be born into its solid form. This is Chapter 1, and it is absolutely one of the most critical stages in the whole process.
Now what's really cool is that our part isn't made from just one pure metal. Nope, it's an alloy. You should think of it like a master chef's secret recipe. It's not just flour, right? It's a really precise mix of ingredients, and each one is added to give the final dish some kind of superpower, whether that's incredible strength, crazy heat resistance, or even flexibility.
So the process kicks off by melting and blending these metals into a perfect liquid mixture. Then comes the moment of truth: solidification. The molten alloy gets poured into a mold, and as it cools, it takes on its new shape. But here's the kicker: the speed of that cooling is everything. Too fast or too slow, and you can build in weaknesses from the very beginning. So, the part has its basic shape. We're good, right? Well, not so fast. It is definitely not out of the woods yet. Even at this super early stage, there are these hidden enemies lurking in the liquid that can just ruin everything before it's even really begun.
And here is villain number 1, Dross. It's basically metal scum, all these nasty impurities that float to the top of the molten liquid. If even a tiny little bit of that stuff gets trapped inside when the metal becomes solid, bam, you've got a hidden weak spot that could cause a total catastrophic failure way down the line. Skimming it all off perfectly isn't just important, it's non-negotiable.
Okay, our brand new part is solid, but it's still pretty soft. It's not ready for the real world yet. So now comes the training montage. It's time for a trial by fire and water to really forge its inner strength. This is where the magic really happens. First, a heat treatment basically bakes the casting in a furnace. What this does is it gives the atoms inside a chance to rearrange themselves from this messy, jumbled-up structure into a tight, organized, and way stronger crystal formation. Then, it gets hit with a rapid quench, a sudden plunge into water, which freezes that new, stronger structure right into place. And finally, a process called aging, which is like a low-heat bake, just settles everything down, locking in its incredible new properties for good. And the results? They are absolutely dramatic. I mean, before this whole process, the metal is soft, it's pretty malleable. Afterwards, it is hard, it is strong, and it's ready for some serious high-performance work. It's truly the difference between a plain lump of iron and a perfectly tempered steel sword. Our part is now strong, but is it perfect? That's the next million-dollar question. It now has to face a whole series of ruthless inspections, a real gauntlet of tests to prove it has absolutely zero hidden flaws. You know, quality control here is a multi-layered attack. First, inspectors get their eyes on it, checking the surface finish for any visible cracks or problems. Then it's X-ray time. This lets them peer deep inside the metal, hunting for those internal enemies like trapped dross or tiny gas bubbles. And finally, every single dimension gets measured with unbelievable precision to make sure it's a perfect fit. Now, when we say perfect fit, what we really mean is that it's within tolerance. Think about it like a key for a lock. If the key is just a tiny bit too big or too small, it's useless, right? It won't work. Tolerance is that incredibly small, acceptable margin of error that separates a part that works perfectly from a useless piece of scrap metal. So the part has passed all its physical tests. But in the world of engineering, there's a saying: if it isn't documented, it didn't happen. So now it's time to earn its official badge of quality through a really rigorous paper trail. It all starts with the standard. The best way to think of this is as the public industry-wide rulebook. An organization like ISO or ASTM, they set the baseline for what an alloy needs to be and how it's got to be made. This is the foundation that everybody has to build on. And building on that foundation is the specification. So if the standard is the general rulebook for everyone, The spec is the specific mission briefing for our part. This is the customer coming in and saying, "That's great, it meets the standard, but for my airplane wing, I also needed to do these 10 extra things."
Okay, next up, you need compliance. This is the proof. This is the mountain of test results, the reams of documentation that show the manufacturer followed every single rule in the standard and met every single demand in the specification. It's them showing their work, plain and simple.
And all that process, all that paperwork, it leads to this. Certification. This is the graduation diploma. It's the final official document from a qualified party that says, "Yep, we've reviewed all the proof, this part has passed every test, and it is officially fit for service." It is the ultimate seal of approval.
So that whole intent journey we just walked through, that was for one single part. But how on earth do you guarantee that same level of quality for thousands or even millions of them? Well, this is where we have to zoom out and look at quality control on a massive scale.
It's simple, really. You can't test every single part, especially if the test actually destroys it. So manufacturers get clever. They produce parts in a batch. Think of it like a single tray of cookies coming out of the oven. Then they take a small sample from that batch. They test 1 or 2 of the cookies, and they measure a specific property, like its strength, or in our analogy, how crunchy it is. If the sample cookie is good, they can be pretty confident the whole batch of cookies is good too.
And here it is. This is the payoff for that entire journey. This chart shows a key property called yield strength. In simple terms, that's how much force a material can take before it permanently bends out of shape. On the left, you see standard aluminum, and on the right, that's our certified part. The difference is just massive. This huge boost in strength also improves its fatigue resistance, which means it can handle stress again and again and again without breaking. This is what all that control and testing gets you: proven, reliable performance you can trust.
So, from a fiery liquid battling scum to a hardened, inspected, and certified component, every critical metal part out there has an incredible story of survival. The next time you're in a plane or even just in your car, trusting a piece of metal with your safety, maybe you'll think about the unbelievable gauntlet it had to run just to earn that trust.